Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. I'm having my coffee break, as you can see. Might just have a quick sip. Have a look at this. Ultra Steve on my Discord had a issue with his Atari 2600 or so, and that it came with an AC to AC power supply, but he only had a DC one. So there was a lot of discussion about what would work, what wouldn't work. So I thought it'd be nice to do a little quick video for Ultra Steve on how full wave bridge rectification works. And remember, I'm by no means an expert, but I shall try to explain using this little diagram I've kind of knocked up, but I've made a few little, not mistakes, but I've been working my way through it myself just to make sure it makes sense. So we have 4 diodes and they're arranged in this direction, and we've got DC, and I'm going to put something in to represent our load here. So this is your Atari. Right there, that's your Atari. So how it works basically is when the current, you have alternating current that's coming from your AC supply, which is doing that. So you can imagine it's this sinusoidal pattern. And there's going to be all sorts of things like capacitors and things on this side to smooth it out. But let's just imagine at the moment it's almost like a square wave. It's just 9 positive and then negative flipping around, which is kind of what it's doing. So you've got 9 volts. Let's say we're at the point where the 9 volts is coming in here. So we've got at the top here a 9 volts, and we've got here a minus 9 volts. And of course I've got some power supplies here in front of me, and this is kind of common in older power supplies. So look, for example, here's one. This is a power supply here for TRS-80, and you can see it has a plus and minus 21 volts winding on there. So if you plug that into the wrong thing, you could have a lot of problems depending where this rectification is. So we're at the point where we've got 9 volts. So what's happening? Imagine you've got the positive here, right? So we're kind of at a positive 9 volts. We've got a negative. And the numbers really aren't so important, but just remember there's the sort of magnitude. Positive this side and negative that side. So the current is currently going to flow through here, down this diode. Can't go here because this is this sort of reverse bias. It's like when you see a picture of a diode, yeah, and you see this door. Imagine this door is like a door. It can't go this way. It has to go the direction of the arrow, and this is a wall. So it's coming through here. It's going through your load, and then it's going to come around here and then up to there. Okay. So remember, this is a negative, right? So it's going to come back through this diode down here and then back to your power supply. So that's the path it's taking. So it's going way through here, and there you go. So that's the potential difference there. And you're saying, why isn't it going, couldn't it go up here and around? That's not how electricity works. Imagine it's like a waterfall. This is the top of the waterfall and this is the bottom of the waterfall. So the water is always trying to flow from the top to the bottom. So if this was literally water pouring in the circuit, it would be pouring around here and going, I'm not going to go uphill, I'm going to go downhill through here. Really, that's a really bad analogy, but it kind of works. Right, so let's flip these around though. So now we're going to have the minus 9 volts part at the top and the plus 9 volts, because this is flipped now and it's going this way. Although I'm saying minus 9, I mean here you're talking, is it 0? Forget that bit, don't worry. So when it's minus, what's going to happen? It's actually not going to flow this way anymore. It's going to flow this way. So it's going to come from this side, coming into here, boom, boom, boom. Then it's going to hit this diode, come up here, can't go up there because it's being blocked, and then round through, and then round that way. Yeah. And what you've noticed on both of those paths, no matter where it comes in, here or here, the positive side of this potential is coming through the positive on the DC. So what you'll see at this point, it's, and I'm going to try, correct me if I'm wrong, anybody. This is going to be the AC wave and this is going to be the DC wave. So if the AC wave is doing that, yeah, I kind of feel what we're going to see on this side, we're going to see a kind of something like that going on. Yeah? It's because it's effectively flipping this negative bit over up to the top. So you're going to get a bum, 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 bum. And then what's going to happen is there'll normally be a big fat capacitor here, like a big electrolytic or something. Yeah? Big electrolytic in here, and then that's going to smooth that, so it's kind of doing a... And the more fancy your power supply, the straighter that will be. Yeah. And that's basically it. So what I thought would be good, the reason why it's important, by the way, and why it's interesting if you can build it into your circuits, is because you can build in reverse polarity protection, okay? So even if you're using a DC input and a DC output, sometimes someone could get those things the wrong way round. You know, like the things where you're putting jumper leads on your car, or crocodile clips, or even, I've got some here I'm going to show you right now. I use these things. There are the opportunities where you could plug those in wrong potentially, especially if we've got something set up like this. So actually I use a set and I actually have them onto one of these. So my opportunity for actually screwing up a device is pretty high if I'm not paying attention or I've got a headache. So what you can do, just imagine this now, we can get rid of the +9 and we can get rid of the -9. And what we're going to do, even again, we're just going to clean up these diagrams because this is a slightly different use case because we're going to be dealing in DC. And if you've got an oscilloscope, by the way, it's very easy to see all these things. What we're going to say now, at the moment, this one now is just going to be positive, plus and minus. We don't care what it is. And we're going to use a DC source, so ignore that. It's just now, this is going to be a DC source coming in. So this could be like 5 volts, like let's say that's 5 volts there. And this is 0 volts, yeah? So that's our plus and minus 5, and we want plus and minus 5 here. So we put the 5 volts into here, that's fine, per normal. You know, maybe it's center positive, it's coming through there, positive there, and then that's going through, and it's going to our 0 volts, great. Now what happens if you plug in your adapter the wrong way and you used a center negative, and we've all got them. I think, is it the Spectrum, Sinclair Spectrums or something, they've got this? You plug it in the wrong thing and you'll blow up your device. It happens all the time. So if you have a 5 volts here at the bottom, so the 5 volts coming in now, you've plugged it in wrong. However, because we've got this full bridge rectifier, it's going to go no problem. So the 5 volts is coming in here, yeah? It's going up through here, through the positive of that DC, back round, and then back to the 0. So you can actually make that pretty easily. I'm going to show you real quick how to put that together. I'm going to assemble this and then show you this reverse polarity circuit. And if you're building it on a PCB or a bit of bedboard, it doesn't take up any room at all. And I'm back. So I was going to contemplate putting it on breadboard, but I thought, actually, why not just build it straight on the picture so you can see exactly what's going on. So what I've done now, instead of having a lot of wires though going around, I've actually just made the circuit internally, and you can see it's just made up of an LED and a resistor. An LED is a really good example here because an LED is a polarity sensitive device, so we can tell if it hasn't worked, because if there's anything wrong with our circuit, then the LED would not illuminate. So that's a polarity sensitive device. So I've got 3.38 volts, plenty of volts coming in off these 2 clips, and they are a DC source. So the red one is positive and the black one is negative. So let's hook it up as if we've gone this way. So we've hooked it up that way, and we're going to power our Atari with our center positive, and you go, whoa, great, it's working. The LED is on. You can see it on right there. And then we're going to hook it up the other way. So this is a really good example to show you that if you've got a device that has an AC input, it could be a lower power, it could be a 5 volt input, not a 240 volt input, right? But it just shows you that it doesn't matter which way round, you see, we've gone the other polarity, which way round you put it, it's been rectified and is working well. And that's the same, as I said, if you're designing your own device, you could always just design it for the cost of 4 of these diodes, and they could be tiny diodes, or you can buy even a tiny little bridge rectifier to go into your own project. You can make it reverse polarity protected, and that, I think, is something worth doing. Thank you very much for watching. Hi, it's me in the flesh. I just wanted a quick message about today's video, because today's video was suggested, or inspired rather, by one of my patrons, Ultra Steve, via the Discord channel. And he mentioned everything, as I said in the video today and in the post, and I went away and created that. And a lot of my inspiration actually do come from the conversations in Discord. But I'd also like to thank all of the patrons. And I actually have the Patreon app on my phone, and I'm going to thank you all in person, not just by writing on the screen. I'm going to thank you in person. So I'm going to like to thank iFixit. Thanks iFixit. They do great tools and great teardown guides on their website. Rob Taylor, Dustin Punt, Gary Pinkett. A lot of active members here on the Discord here. The Dutch Retro Gamer, thank you, sir. Steve Green, Jonathan Smith, Techmoan, Chrissy, Lorne Smith, Andrew Dalton, and you know Andrew because he's on a lot of the streams as well. Robert Rowland, Eagle Stalland, Kevin Lee, Nostalgia Nerd, Retro Man Cave, Dan Stott, Verdi RD, Zed, Hannah Cass, Chinny Hill, Michael Turner Craig, Bjorn Eckert and Bruce Morga. And actually, Bjorn Eckert and Bruce Morga are contributing to Patreon, and they've chose to donate without any reward. So wow, thanks guys. And thank you all for really helping support the channel. You've actually changed the dynamic so much because now it gives a purpose for me to do things. You know, you suggest things and I'll go out and make a video on them. So it's really invigorated me. So I hope you've enjoyed today's video and I hope you enjoy the future ones. As ever, thanks for watching.